Alright, so I hope that you have gone through all the previous videos for exception handling, part 1, part 2 and part 3. So here is part 4 of the video, and this is going to be the last part. And what we're going to do here is we're going to learn the last 3 things which are left, which is rethrowing exceptions and exception handling in classes. Well, I'm just going to give you an example of how you can handle exceptions in classes. Like, there is nothing new, but just a usage. I'll show you exactly how we can work with exception handling in classes, and then we will talk about the set terminate function, which is an important function, and it's useful to know this because many times during the placement interview they ask you what exactly the set terminate function is. Alright then, so let's get back to the page where we had actually, to the slide where we had actually left, and we will continue and see exactly what we mean by rethrowing exceptions. Now when you have a try block, let's go back to this slide and just go through it. So when you have a try block, you'll have to have a corresponding catch block. Now when you throw an exception from the try block into the catch block, there is an option of rethrowing an exception from here into another catch block. Alright, so how does that actually work? Let's look at it. So before we actually look into an example, let's just go through what rethrowing of exception really means and how it can be useful. Now the exception from the catch block can be rethrown. So when you're rethrowing an exception from the catch block, you must remember that we need to have another catch block where that exception will be caught, right? And it is done by using the throw keyword without any arguments. So when you have just the throw written inside the catch block, right, you know that we are rethrowing the exception. Alright, so when you're throwing an exception from the try block, we need to use the arguments. But if you're rethrowing it from the catch block, there is no need for any arguments. You just need to use the keyword throw, right? And they are useful when there is multiple try catch block. So we will see an example of how that is done. Now also a function, the structure of the function is that it's divided into 2 parts. So you can have a function call and the function body, and they are at different places in the code. So you can have a try block around the function call, and that try block can have a corresponding catch block. Similarly, once the control goes to the function body, then inside the function body also you can have a try block and a corresponding catch block. So let's use a function call and a function body to see exactly how we can rethrow an exception. Yes, so let's look at this example. Now here we have a main method and I am making a function call here, right? And this function call, that is calling the function logic, and I'm passing a double here, is inside the try block. That means for this try block I need to have a catch block, and here is my catch block. And this catch is going to catch a double. So that's fair enough because X is going to be a double and we are catching a double here. So that's fine. For this try, we have a catch here. Now, inside the body of the function, that is logic, which is accepting a double, we have a try block. And this try is basically to catch an exception, which is value 5. So if the value 5 is entered as X, it should be caught as an exception. And for this try block, the corresponding catch block is here. Right? So the normal flow of control would be that if somebody enters double here, somebody enters double here, the X will come here as 5. If somebody enters a double with the value 5, I mean, so if X is equal to 5 here, then it will come here where logic 5 is going to be invoked, and this will go to this block. And here, if D is equal to 5, an exception is thrown, which is D is thrown, and it will go to the corresponding catch block. The catch block has the argument double D, so there is no problem. It matches, and then it comes inside and you get something printed as exception. However, now you find something that there is a throw. Now what exactly is going to happen here is this 5 is going to be rethrown. So where is it going to be rethrown? So it will exit this code. That means when you exit this code, you reach here. And when you reach this part, an exception is thrown here. So what is going to happen is that exception will be rethrown to the catch block of this try. And the catch block should also have a similar argument. So in this case, we are throwing a double and this catch has a double, right? So this this value d is equal to 5 is actually caught here first, and then this throws it back to this catch block, and here it is printed. So this is an example of how exception is being thrown here. So how will be the control in which the things will move? So first of all, it will come here, then we go here, this will call this, and we find that d is equal to 5. Exception will be thrown here, and again we have rethrow of exception, so eventually this will be rethrown here. Now this is how exception can be rethrown. Right? Now one thing to remember here is when you're rethrowing an exception, it has to be thrown into a catch block, and that catch block should have the similar argument. So if you're throwing an integer here and you don't have an catch block with an integer argument, then there will be a problem. Alright, so this is an example of how you can rethrow an exception. Now, although this is not a very specific thing to kind of study when how you actually handle exceptions in classes, or how you can do exception handling in classes, but I'm just going to give you a small example of how you can use it. There is nothing that is technical here. There's a new concept which comes into the picture here, but I'm just going to give you a small example of how you can restrict creation of an object depending on what the user has entered. So for example, if I am using a parameterized constructor to create an object, and I want the user to enter an appropriate value for that, and accordingly the object has to be created, I can control that by using exception handling. So you can just go through this slide, but let's look at an example. Now here what I'm doing is I have created a class called as A, and that class has got a destructor as well. So I've written a destructor, and I have a parameterized constructor which is accepting a double here. And if you look at it, these are the two lines of code which is going to create an object and invoke a method. So I'm creating an object called AA, and I'm passing the value 0. Now I have a try block, so this part of code is inserted inside a try block, and I need to have a corresponding catch block. So in this corresponding catch block, I have used the argument as double k because I'm trying to work with the double value. Alright, so any exception which is thrown through this try block has to be a double. Alright, so now how is the program control going to be? Now when you encounter this line of code, that means a constructor is going to be called. So when a constructor is going to be called, we go here, right? And here 0 is going to be passed. Now if you look at this line of code, I have written if k is equal to 0, that means 0 is my exception. So any other value other than 0, there will be no problem. This constructor will get invoked completely. The k value will be inserted into f, and an object will be created, and you can actually show the value through the show method. However, if the value of k is 0, then an exception is thrown. So exception will be thrown here. Now when an exception is going to be thrown here, that means this is also a part of the try block, because we have gone this way. This is how it's going to work, because when you you're invoking a method and you go all the way to the method body, and the method body is actually a part of this code, right? So when you actually invoke the constructor and there is an exception here, this throw is basically a part of this try block. So from here, what's going to happen is this k will be thrown to a corresponding catch block, which is going to be this. Now, do we have an argument of the catch block as a double? Yes, we have. So this k will be caught here. Now, this simple example tells you that you're restricting the object from being created if a user is passing a specific value in the constructor. Now this can be a very useful mechanism by which you can restrict creation of an object unless the appropriate values are entered, right? So it's a very simple example. There is nothing complex here. Only thing you must remember is that you have to use an appropriate catch block to catch an exception. So if the exception is a double, the catch block should have an argument which takes a double. And that's been a normal rule all this while. All right. So there's a last part of this, which is basically an add-on, right? I just want you to know this for your placement, and also there's no harm if you just remember it for your exam also. You can get a 2 marks question on this. Now, what exactly happens when you don't have a matching catch block? Now, in your code, there could be a scenario where you're not able to visualize that there could be an exception. However, the exception can happen, right? I'm not talking about the business logic exception. I'm talking about the normal exception, like, array out of bounds. There can be an issue with the array. You can be an issue with the file not existing. There can be issue with the database connectivity, or anything for that matter, or even for an arithmetic expression which can be divided by 0, that kind of exception, right? So if you don't have a catch block, sometimes we might miss out on that. You don't want the program to crash. So there is a mechanism in C++ wherein if there is an exception that happens and you don't have a corresponding catch block, there is that last function. So what the compiler can do is it can invoke one last function where you can probably write some message. That means if you have an exception, very good. If you have an exception handling code where you're catching an exception, you're throwing it to the catch block, absolutely great, no problem. But in case you have an exception where you don't have a catch block, you could not figure out what the catch block would be, in that scenario what will happen is there will be a function which will be triggered, and that function is called as a setTerminate function. So this function is used to transfer the control to specified error handling function. Now the important thing is, rather than going through this the theory, let's look at a practical program, and then you can relate to the theory later on. So here is a small example. Now don't look at the setTerminate function as of now. So it's a simple void main inside which there is a variable that I've declared as x, and you can enter the value for an x, and then if you have x is equal to 0, you throw this x, right? Otherwise print the value of x. Now if you notice here, I am throwing x, which is an integer, right? But my catch block is accepting a character. Is there a mismatch? Yes. That means there is no catch block for this throw. That means there is no catch block which can catch that exception which is being thrown. So in this case, what is going to happen? There's going to be an error, right? Because we could not figure out what the exception is going to be. We have catch block for different exceptions, but not for the exception which is throwing an integer. So in this case, if you don't do anything, you will get an error. However, there is an option of declaring a function. Now if you look at this, on the top of the main method, I have declared a function called set_terminate. Now this is a function which is given by the compiler. It's not your own user defined function, but this is a function call which this function belongs to the compiler, and the argument of this function will be another function. Now this fun that you see here is basically a function that you have defined. So that's here, right? And normally this function should be a function which just prints a simple message and exits the code. You should not be returning values from here. You should not be doing computation. You can't be doing any other thing other than exiting neatly with a nice simple message, right? So what happens is, this is an important function. Now this is an example of a function which takes in its argument another function. Now this is a very unique function. Please remember that. The argument of setTerminate function does not take a data type, but it basically takes a function name, right? This function name you need to define. All right. So what happens when you have a setTerminate function defined? So in this case, when the compiler finds that there is no catch for an integer, it should normally throw an error and exit the code. However, there is that last support or that last bit of code that the compiler can trigger for you, and that would be, it will check whether there is a set terminate function which you have defined. So in this case, since it is defined that the set terminate function is fun, once it finds that there is no catch block, it will invoke the set terminate function. And here you can print out a very simple piece of information, like for example, there has been a system error and your program is shutting down, please restart again, or there's some error which we are looking at it, we'll fix it, come back soon, and then you exit the code, right? So this is an usage or the functionality of the set terminate function. Now you please remember this, because sometimes they ask in the placement interview as one of the functions which takes another function name as its argument. All right, so this is the end of exception handling, and it's a very simple chapter and not very complex, not connected with object-oriented programming, but additional extension of C++. So go through it, and if you have any doubts, you can always ask me offline, online. So see you.